यूरोप का सदर
Welcome to NASA's coverage of the 2023 annular solar eclipse, live from Kerrville, Texas. I'm Tahira Allen with NASA Communications, and I'm joined today by Dr. Gina DiBraccio, the Deputy Director of our Goddard Space Flight Center's Heliophysics Science Division. Gina, thank you so much for being here with us today.
Thanks for having me, Tahira. Happy to be here.
I mean, it's a big day for heliophysics, which is the study of the sun and its effects across the solar system. So, Gina, I'm dying to know, how are you feeling right now?
I'm thrilled. We've been planning this day for such a long time, and I can't believe it's finally here. It's so exciting.
And I mean, you couldn't have asked for a better day, folks. It's blue skies. We've got the sun beaming. It's incredible.
It's great.
And so today's celestial event will be visible for millions in the Western Hemisphere, with 48 contiguous U.S. states and parts of Alaska witnessing at least a partial eclipse. Now, some cities, like Kerrville, Texas, are in what's called the path of annularity for today's events. So, Gina, can you break down what that means and what somebody in this path can expect?
Sure, Tahira. So when a solar eclipse happens, the sun, the moon, and the earth are all in line. Now, for an annular eclipse, the moon will be just a little bit further away from the earth than during a total solar eclipse. And that means when the moon crosses in front of the sun, we're left with this ring of fire that we see in the sky.
That is going to be incredible to witness in person. And folks, the eclipse has already begun sweeping across the United States. First starting in Oregon at 9:13 a.m. Pacific and ending in Texas at 12:03 Central. From there, it will continue its path through Central and South America. Now keep an eye on the telescope feed in the box on your screen. We're going to be sharing live views from across the eclipse path throughout today's show. Now, Gina, is there a way to know what kind of viewing experience I can have in my city?
Sure. So our viewers can go to go.nasa.gov/Eclipse Explorer, and that will take you to that interactive map that we have, and you can see when and what your viewing experience will be.
That is amazing. Thank you so much, Gina.
Absolutely.
And folks, if you go ahead and look at that feed in your screen, this is a live view of Kerrville, Texas, and you can see the moon is already starting to inch across the sun right now. So again, this is a good time to mention where this eclipse goes today. We go during today's broadcast. So if you're not in the path of annularity and still want to see that ring of fire effect, don't worry. Our friends from Time and Date are bringing us live telescope views from across the path of the annular eclipse, starting first in the United States and then following the action as it sweeps across Central and South America. We have a lot of exciting things planned for you throughout the show. You're going to see what it's like inside a hot air balloon at the world's largest balloon festival. We'll then check in with astronauts aboard the International Space Station. You'll hear from a very special guest about eclipse safety, and then learn all the ways you can participate in next year's total solar eclipse. This is going to be the last time a total solar eclipse passes across the mainland U.S. for 2 decades. Now, you can interact with our experts in today's show by sending in questions using the hashtag AskNASA on social media, or by dropping them directly into the comment stream wherever you're watching. Now, Today we are here for an annular solar eclipse. But did you know there is actually a difference between an annular and total solar eclipse? Now imagine the sun is having a spotlight show in the sky. In a total solar eclipse, the moon moves right in front of the sun and covers it up like a big curtain, making everything dark for a little bit. It's similar to what you would see at dusk or dawn. Now, because the moon is completely blocking the light from the sun, we're able to see the sun's corona during a total solar eclipse. Now, in an annular solar eclipse like today, the moon is going to be a bit too far away to completely cover the sun. So like Gina said, when you look up at the sky, you're going to see the sun with a glowing ring around the moon. Because of this, it is often called a ring of fire effect. And as you can see on your screen right now, it is going to be a really, really cool and unusual sight. Now, a word of caution though, because the sun is never completely covered during an annular eclipse, it is important to always wear your eclipse safety glasses anytime you look at the sun. Now, both types of eclipses are amazing shows, just with different perspectives. So today we're going to be bringing you views of the annular eclipse, and you're going to have an opportunity to view a total solar eclipse on April 8th, 2024. Now, Gina, anything you would add to that?
Of course, Tahira. So the science. With the annular eclipse and the total solar eclipse, we can do great science, and NASA has a bunch of experiments, which you'll hear about later today.
Fantastic. Thank you so much, Gina. And folks, it's time to meet your other hosts. We have James Traley at our eclipse desk. He's going to be keeping us keyed into the action, connecting with telescope operators across the country to show us live views as annularity sweeps the nation. And we also have Joy Ung and Michael Kirk at our Albuquerque desk. They're going to be joined with special guests throughout the show to talk about how important eclipses are to all the science we do at NASA and how you can play a part in the activities leading up to 2024's total solar eclipse. Now we're going to head out to Joy and Michael later, but first, James, how are things looking on your end?
Hey, Tahir, so excited to be joining you live from Kerrville, Texas. I've got my eclipse glasses ready to view today's big event, the annularity, right here in just a few moments. We should be getting our first view from the West Coast in just a few moments. Up in Eugene, Oregon, we'll have the first awesome view from the United States. And you can track all of today's events using this interactive tool we've developed called our Eclipse Explorer. If you want to play around with this, go to go.nasa.gov/Eclipse Explorer. This is a fantastic tool that allows you to preview exactly what the eclipse is going to look like in your neck of the woods. You can see this path that it's going to be taking all the way down to us in Kerrville, Texas, starting out in the Pacific Northwest. But even if you're outside of that area of influence, say, for example, you're watching today's broadcast live from Milwaukee, you'll get a great view of a partial eclipse. And these little icons that you see here, these little googly eyes, if you will, they're actually clickable. So if I go to Eugene, they're supposed to have peak annularity beginning at around 9:17 a.m. Pacific. If I click on this little googly eye, it'll snap right to that time, and you can preview exactly where it's going to be. So you still have plenty of time to start getting up to speed with exactly what this annular eclipse or partial eclipse is going to look like in your neck of the woods. So I certainly encourage you to play around with this tool. And if we go to our real-time view of it now, you can see that a partial eclipse is already impacting a very large portion of the United States, stretching all the way out to as far as Nashville. And so very excited for our moment in this partially eclipsed sun here in Kerrville, Texas. We're expecting that to begin at around 11:50 a.m. local. I'm going to continue to track the movement of this annular eclipse across the U.S. But for now, back to you, Tahira.
Thank you so much, James. So excited to see that first instant of the Ring of Fire effect soon. Now, Gina and I are joined with Leslie Garrison.
Hi, Leslie.
Who is going to show us how to make a pinhole viewer to observe today's events if you do not have your eclipse glasses. So Leslie, I see you've got a few different pre-built pinhole viewers with you right now. Can you first just walk us through how this even works?
Yes, absolutely. So to safely view the sun today, we brought a couple of items. We have a colander, a pinhole, a peg hole, a sheet of cardstock, and a hole punch. And so we're going to use them to simply create what we call a pinhole projector. And so in order to use these or to make these, you need a few items from home, but number one, make sure to never look at the sun directly, but number two, make sure when you are making and creating and using these that the sun is to your back so that the sun's light can cast light through the holes.
And you just put it up and have it put a shadow on the ground?
Absolutely. And so on the paper model, we are going to put a hole here and the light is going to go directly through it. Peg hole, the colander, and the NASA 3D printed model already has a hole. All you have to do is wait for the eclipse to happen and see the view of the sun on a surface area.
That's great. So Leslie, can you go over those materials just one more time?
Absolutely. So at home, you probably already have a colander. This is just a pegboard toy from my son's toy box, and a sheet of cardstock and a hole punch. But NASA has a cool event online. You can see our URL somewhere on our screen, and you can go online and make these items at home to use.
So really, you just need something with a hole.
You need
that
something
can
with a hole.
Yeah.
The sun's light can shine through, so on the surface area, and you can see the eclipse on that surface area.
Simple,
Great.
effective.
Yeah.
Leslie, thank you so much
Thank
for your
you
help
for having
today.
us,
Leslie.
And folks, this is a good time to remind everybody that it is dangerous to look directly at the sun without specialized eye protection for solar viewing during today's events. Now, we have a very special guest that you might recognize popping in to share some important tips to make sure that you stay safe during an annular eclipse.
Hi, eclipse enthusiasts. Lance Bass here, and I want to tell you how to protect those eyes and stay safe during a solar eclipse. During these celestial events, the sun, earth, and moon are in sync, creating solar eclipses. During an annular eclipse, it's not the moment for a sun staring contest. Grab those eclipse glasses and shade your eyes from the ring of fire. What you'll witness is a true cosmic marvel. The moon will move between the sun and the earth, but the moon is a bit too far away from Earth to completely cover the sun. So, when you look up at the sky during this annular eclipse, you'll see the sun creating a glowing ring around the moon. Because the sun is never completely blocked, it is never safe to look directly at an annular eclipse without special eye protection for solar viewing. This I promise you. You should wear eclipse glasses so that you don't say bye to your vision. Seriously. And eclipse glasses are not the same as regular sunglasses. No, they're not. Safe solar viewers are thousands of times darker and will have a specific certification that you should look for right here. Don't be a space cowboy and try to look directly at the sun. If you don't have eclipse glasses, you can use an indirect viewing method, like a pinhole projector. You can make one of these with something as simple as an index card with a hole, or a colander, or even your hands. With the sun at your back, you can safely project an image of the sun through the hole onto a nearby surface like the ground. It's gonna be me who is wearing my eclipse glasses, and so are you.
Now, don't forget to be in sync with these safety tips, folks. Seriously, listen to Lance and protect those eyes. We really want everybody to enjoy today's events. Now, let's check in with Joy and Michael in Albuquerque, New Mexico. Joy, Michael, how is the energy over there?
Hi, Tara and Gina. The energy in Albuquerque is buzzing. We are so excited for the annular eclipse to pass through New Mexico in just under an hour. I'm joined with one of NASA's eclipse experts, Dr. Michael Kirk. Thank you so much for joining us.
Oh, it's an absolute honor and a privilege. I'm so excited to be here today.
So we're currently on the grounds of the Anderson Abruzzo International Balloon Museum in Albuquerque, and behind us the Albuquerque International Balloon Fiesta is also happening. And in fact, a balloon is also about to get inflated right behind us, which is really, really exciting. So Michael, have you seen an annular eclipse before?
I have seen an annular eclipse in New Mexico back in 2012, but this is a special event here today. With the balloon fiesta going on, there are literally thousands of people behind us, all getting ready for this event. This is one of the most special eclipses I've ever been to.
This will be my first annular eclipse. I'm really excited, and the skies are looking really clear, so I have my fingers crossed that it stays that way. So we have these incredible balloons over the past week, but did you know that NASA also does science experiments and develops technology using balloons? They're slightly different from hot air balloons. So to learn more, I chatted with Chris Yoder from NASA's Scientific Balloon Program. Hi Chris, thank you so much for joining us.
Thank you for having me.
So you're part of NASA's balloon program. What is the difference between a NASA scientific balloon versus a regular hot air balloon?
Good question. So hot air balloons are air-filled, and the air is heated to create the buoyancy and the lift that it gives. Generally, they float at a couple thousand feet. They go up and down at a Scientific balloons, on the other hand, are quite different. So Our largest balloons can fit a football field inside their equator, and they can fly for much longer. So
चलो मैं लाना साहब
payload capacity is
Check
about
करना।
8,000 pounds, double SUVs. The duration can be
ਇਹਦਾ ਸਟਾਪ ਕਿਹੜਾ ਹੈ
up to 5 or 6 weeks at a time, and the altitudes can
ਉਹ
be
ਸਟਾਪ ਕਿਹੜਾ ਹੈ
1,000 feet, about 4 or 5 times the height of a commercial airliner.
Wow.
ਚਲੋ 429 55
That's incredible. And you launch all over the globe. So you launch from New Mexico in the US, New Zealand, and even McMurdo Station in Antarctica. Why do you launch
चलो मैं
all
कर
these
लेना।
different places?
In short, we go where the
मैं कर
science
लेना
needs
पास
us to go.
एक और गड्डी से चेक
Some
कर
scientists need
गड्डी को
northern
लाना
hemisphere
वेट
science for galaxies and star formations. That's why we go to Sweden. Same thing in the southern hemisphere. That's why we go to Antarctica. Most missions need some kind of trial or test system. So they'll fly from New Mexico to prove their science or even just collect science at a shorter duration. And then for missions that are a little more risky, we'll go out to PMRF in Hawaii.
So can you describe to me what launch day is like?
It's an incredible feeling, right? So you see the balloon be released, you hear the rustle of fabric and the rush of the wind as it stands up. You see the balloon be released from the vehicle and ascend, and it just gives you chills every time you watch it. It's a really great feeling.
और
That sounds
शादी
incredible. So how many of these balloon
Hello?
experiments have been sun focused or eclipse focused?
हेलो
So about 8 to 10% of our portfolio is heliophysics
Hello?
missions. One of the ones that stands out in my mind is one I got to see launch in 2019 from New Mexico. It's called the BITSI mission, and it was looking at the corona, or the kind of the outer edge of the sun, and looking at how that behaves under different conditions.
That sounds amazing. Thank you so much for joining us.
Thanks again for having me.
Our balloon program has been around since 1961, so it's no surprise that our balloons are constantly innovating and discovering new science. So let's dive into some of the big science discoveries that have been made with scientific balloons.
High above Earth's surface floats a critical tool in NASA's exploration arsenal: scientific balloons. Massive, helium-filled, high-tech balloons lift heavy scientific experiments into near space to get a clear view of our planet and the
और
cosmos.
शादी
Launched around the globe, these unique NASA missions provide a fast and cost-effective alternative to rockets to study Earth, our solar system, and beyond.
ठीक हो गया और उसके बाद
Balloon science has led to many important discoveries. For example, astrophysicist John Mather studied heat from the early universe using balloons, which later contributed to his Nobel Prize-winning work confirming the Big Bang theory of an expanding universe. A special type of high-altitude balloon can carry telescopes above the clouds for extended periods of time to study the dark matter in distant galaxy clusters. One of these superpressure balloons, called Superbit, captured the Tarantula Nebula 160,000 light-years away. This winter, crews in Antarctica are preparing to launch the Gusto mission. Its infrared telescope will examine the complete life cycle of a star. NASA's scientific balloon program, guiding a path to discovery above and beyond.
ठीक हो गया
Joined with us now is the Balloon Museum Manager, Nan Maslin. Thank you so much for joining us on probably the busiest week of the year.
I'm so happy to be here with you all.
So we're here, the Fiesta started in the 70s with a small group of people, and now there are hundreds of balloons. Can you tell us more about the event and what it means to the city?
Absolutely. Well, it started in 1972 by a pilot named Sid Cutter, who had the idea to get a few hot air balloons together. He managed to get 13 together in a mall parking lot, and they expected a handful of people to show up, and hundreds did. And that's when he knew he was really onto something. And 51 years later, there's 100,000 people behind us on the field right now.
My goodness. So the Balloon Museum, it's where you work and it's where we are right now. Could you tell us a little bit about the relationship between the Balloon Museum and the Fiesta itself?
Absolutely. We are very good neighbors. We are here 365 days of the year. We started in 2005, and we start with the early ballooning in the 1700s up through today, exploring the history, science, art, and just wonder of ballooning. And if you haven't been to Albuquerque, we invite you all to come back and check out this museum.
And what do you love most about the Fiesta and the museum this week?
New Mexico is such an enchanting place to be, and the smell of roasting green chili in the air, there's nothing like it. There's a reason why Georgia O'Keeffe chose this place as her home. It's because of the open sky and the beautiful landscape, and we get to enjoy so much of that here. And when you think about it, there's like a spotlight shining on Albuquerque, and I think it's probably the best place in the whole wide world to be right now. Today, Balloon Fiesta and an annular eclipse. I can't imagine anything better.
And how do you feel about an annular eclipse falling at the same time as the event this year?
It's just fantastic. I'm so happy to be here with you all, and Mother Nature has provided us the perfect sky today. Looking this direction, I don't see a single cloud. There's a bite out of the sun already, like it's bitten out of an apple, and I just am so excited to see the annularity.
Amazing. Thank you so much for being with us today. I'm really excited to enjoy the annular eclipse together. So next, we are honored to hear from NASA Administrator Bill Nelson.
Hey everybody, we're so excited that you're joining us today for this solar eclipse. It's when the moon passes between the Earth and the Sun. It's a big day for NASA scientists because eclipses present unique opportunities to study the Sun. And what we learn from these eclipses, along with our heliophysics research, has incredible benefits for our human exploration. The sun is a powerful, hot, glowing ball of hydrogen and helium, and it actually holds together the entire solar system. Without its energy, we couldn't exist here on Earth. Just think, it influences everything. What we do on Earth, growing crops, our economics, it even affects our physical, mental, and emotional well-being. We see its influences reflected throughout our culture as well, in art, music, religion, sports. When you look up today through eclipse glasses, I hope you're going to remember all the ways that the sun impacts us. NASA will never stop studying our closest star for the benefit of all of us, terrestrial beings here on planet Earth.
Thank you, Administrator Nelson. So, Michael, we've been getting a lot of questions on social media. Shall we dive in?
Yeah, let's do it.
Okay. So, I have a question here from Priyesh Patel on YouTube, and they ask, do events like eclipses occur in a similar pattern geographically?
Oh, absolutely. Geographically, we get the same sort of shape of an eclipse that will move slightly northward in its progression. So this is called the Saros cycle. And every 18 years or so, there's a repeated pattern of an eclipse, and the pattern itself repeats a little bit further north each time. And so we get these overlapping patterns that are exactly the same over time.
Amazing. I didn't know that.
Yeah.
That's really surprising. Okay, and before I go on my second question, I just want to mention that in the telescope view now, we are seeing a partial eclipse and a lot of bite out of the sun.
Oh yeah, it's getting a bit bigger. We're not quite to 50% yet, but yeah, it is getting there. It's pretty exciting.
That's so exciting. Okay, so the second question I have is Sammy Connor on YouTube, and they ask, how does the Ring of Fire eclipse affect the light from the sun reaching Earth?
Ooh, that's a fantastic question, because it has something to do with the science that we can do with eclipses as well. So as the sun gets blocked by the moon progressively, there are parts of the sun specifically that will be blocked, and the light from the active regions won't be able to hit the Earth's atmosphere. So we can actually study the effects. We can actually study these effects. We'll hear a little bit more about this later in the program.
Amazing. Okay, so a third question is, one of our viewers on YouTube asks, how do eclipse glasses work?
Ooh, that's a great question.
So these things.
Yeah, we have eclipse glasses. Okay, so you see the lenses right here. This is a mylar film, and the coating on it blocks over 99% of the white light that comes here. Blocks infrared and ultraviolet light, so it keeps your entire eye safe. So it's really that coating that keeps us safe from the powerful sun's light.
I'm glad.
Yeah, me too.
Thank you so much, Michael.
Of course.
So remember, wherever you're watching in the show, ask a question in the comments below using the hashtag AskNASA, and we'll be answering more later today. So now let's head back to Tahira and Gina in Kerrville, Texas.
Thank you, Joy and Michael. The weather looks great in Albuquerque, New Mexico.
It does, yeah.
So, folks, if you're just joining us, we're following the 2023 annular solar eclipse as it sweeps across the Americas. Now, coming up soon, James at our eclipse desk will be plugging us into our very first views of annularity taking place in Eugene, Oregon. Now, Gina, as we anticipate this beginning first moment, can you walk us through what exactly is happening when an annularity takes place?
Sure. So when the annularity is taking place, that's when the moon is going to be in front of the sun. Now for the annular eclipse, it's not going to completely block the sun, so we'll have that ring of fire that we get to see in the sky. And if you take a look at that live feed from the telescope that we're seeing right now in Kerrville, we already have a bite taken out of the sun from our perspective as well.
Wow, and so that's just going to pass directly over, but not fully cover it.
Exactly. We'll still have that ring peeking out.
Beautiful. And I mean, we're seeing something, but will anything else happen? Like, will we feel anything?
Yeah, so that's the fun thing about these solar eclipses is the fact that there will be environmental changes. So we'll feel that temperature drop, maybe a change in humidity and wind as well, but also nature will respond. So check out, how it feels around you. The birds will nest and go back to their trees. The crickets will come out, starting to chirp. It'll feel kind of dramatic when this happens too.
Can't wait to feel that with you today. And folks, I mean, it's not just us here on Earth plugged into today's action. Emily Ferfaro with NASA Communications had a chance to chat with two astronauts aboard the International Space Station to learn more about the sun from their unique perspective off our planet.
Jasmine, Satoshi, this is so exciting to be talking with you. This is the coolest thing that I've ever done. As you know, all eyes are going to be on the sun on October 14th as we experience an annular solar eclipse. And so I'm wondering, have either of you ever seen a solar eclipse of any kind?
Emily, actually, coincidentally, my very first day at NASA was August 21st, 2017. Which was an incredible solar eclipse. All my classmates and I got to go outside and stare up with everyone, pretty much everyone else at NASA was outside in those moments looking at the solar eclipse. So that's something I'll always remember.
Wow, oh my gosh, what an incredible first day that must have been. Solar eclipse events provide scientists with a unique opportunity to study the sun in different ways. So with that, I'm wondering, how do you study space weather and impacts from the sun on the International Space Station?
Well, Emily, from the International Space Station, we have a really unique vantage point looking back at the Earth. But also there are several experiments actually mounted right outside here on the Japanese experiment facility outside of the GEM module.
Regarding the space weather, specifically from solar flare activities point of view, specialists on the ground kindly observe it continuously, and when there is a big solar flare, they notify it of us, and we move to a relatively safe place on the International Space Station.
Wow, I am so glad that you're well protected up there on the International Space Station. I want to touch back on the annular solar eclipse. This celestial event kickstarts NASA's Heliophysics Big Year, which is a global celebration of sun science and a year where we're inviting the public to do as many sun-related activities as possible. So I'm wondering, what is your favorite thing about the sun?
Well, Emily, for me, I don't particularly like the dark, and I don't particularly like the cold. So I'm a big fan of the light and the warmth that the sun brings. We wouldn't be the planet we are without the sun.
Emily, I echo Jaws, and I like the brightness and the warmth of the sun, and I'm looking forward to the next solar eclipse.
That reminds me of something that my friends in heliophysics say, that the sun touches everything. With that, I want to thank you so much for taking the time to chat with me today about the sun, and I hope that you both have a great view of the eclipse wherever you might be. And good luck with the rest.
Thanks so much, Emily. Have a good one.
Station, this is Houston ACR.
ਆਕਰਾਮੈਨ ਸਨ ਤੇ ਪਾ ਦੇ ਇਹਦੇ ਵਿੱਚ 180 260 ਦਾ ਵੀ ਫਿਰ ਲੱਗ ਜਾਏਗੀ ਨਾ
Can you imagine seeing the shadow?
260 ਦੀ ਲਾ ਦੇ 20 ਦੇ ਵੀ 40 ਆ ਬਸ ਆਕਰਾਮੈਨ ਸਨ ਤੇ ਪਾ ਦੇ ਫਿਰ
Now,
60 ਦਾ
folks, the crowd is growing here in Kerrville, Texas,
Oh.
as we inch closer to our moment to witness that Ring of Fire effect in person. Now, it's a good time to check in with James at our Eclipse desk. James, how are things looking on your end?
Hate to hear it. Yes, so we're still just a little bit away from the annularity here in Kerrville, Texas. Really cool to see the science going on in the International Space Station. Coincidentally, there's actually some really cool science going on just a little bit to the west of us in just a few moments in White Sands, New Mexico. And right now I'm actually joined by scientist Jamie Favors, who can walk us through exactly what we're about to see with this sounding rocket launch. Jamie, thanks so much for joining us.
Thank you so much, James.
Yeah, so is this your first annular eclipse?
It is, yeah, and first time launching rockets into an eclipse too, so.
Amazing, and we're about to have the first of 3 launches. I understand we're kind of timing these launches out to specific times here, right?
Yeah, so you're exactly right. So we'll have 3 launches during the eclipse, about 35 minutes before the peak. That'll be this first one, right in the middle of the peak, and then 35 minutes after the peak. Studying that upper atmosphere, the ionosphere, kind of see what are those impacts from the sun that really change, important features of the upper atmosphere that impact things like radio communications, satellite operations.
And we just had a launch yesterday in Cape Canaveral, Florida, of our Psyche mission. That's going out into deep space, but these rockets, which just launched actually here, this just took off, so this is actually going to come back down afterwards.
That's right. So we're seeing first stage burnout here, about 6 seconds in. Blink out for a second, so the rocket's still moving along. There we see the rail, the pad that we just launched from. So as we're launching into space, we're going to start making measurements. Roughly about a minute into launch, so we're a few seconds in now. I bet we're getting pretty close to the second stage, lighting off at this point to take us all the way into space. So roughly that 1 minute mark is where we start to do a lot of the science. The payload separates from the rocket. We have some deployables we'll release from that payload out at that point. We'll start moving that payload around in space so that it's starting to make good measurements. We have these booms or arms that come off of the payload, start making different measurements there of like magnetic structures, electric structures in the upper atmosphere, as well as temperature and density. One way to kind of think about this, what the shadow of the eclipse is doing in that upper atmosphere is it's creating these waves as all those temperature and density changes are occurring. So kind of think about it in the way of like a boat moving through the water. Yeah. We've all seen a boat move and you see the waves propagating out from or moving away from the boat. The same thing is happening here with the eclipse and that shadow. So with those 3 rockets, we're launching one right before the boat moves through, one right in the middle of the boat coming by, and then one right after the boat moves through, or the eclipse shadow.
Sweet, and so we are just now a couple minutes away from actually getting annularity here in Kerrville, Texas. Our first view is actually going to be up in the Pacific Northwest, up in Eugene, Oregon. They are going to be experiencing this starting at around 9:17 local time. Jamie, thank you so much for joining us. Best of luck for the next 2 launches.
Yeah, thank you so much, James.
Back to you, Tahira.
Wow, I mean, if the day wasn't exciting enough, now we've got a rocket launch in the mix. This is so exciting. It's incredible. And I mean, what a NASA broadcast, right? And so thank you, James and Jamie. Now, Gina, we have a lot of great questions rolling in from our viewers online. How do you feel about taking a few?
Let's do it.
Okay, let's do it. So our first question is from Entertainment on Facebook, who asks, how often do eclipses happen?
Great question. Well, thank you for that. So there are actually eclipse seasons. And so we can get eclipses about 2 to 3 times a year. You might expect them to happen every time there's a new moon, but that's not the case because the orbit of the moon is tilted by about 5 degrees, which means sometimes the shadow is a little too high and it doesn't hit Earth, and sometimes a little too low. So we need those eclipse seasons as that sweet spot.
Okay, nice. And so I actually have a really great follow-up to that. Okay. Spectacular Science Podcast on YouTube asks, how do you predict solar eclipses then?
Okay, well, it's actually pretty straightforward how to calculate the eclipses because we have a good understanding of the moon's orbit. We have a good understanding of the Earth's orbit and how that whole system is connected. And so we kind of take the geometry and the inputs that we have, and we're able to pretty accurately predict those. And so these are things that we can look out decades in advance to understand when eclipses can occur.
Oh, cool. And so how often would an eclipse pass in the same city? Do you know?
Well, so for total solar eclipses, it's very unique for an eclipse to pass more than, it's about once every 375 years that a location can experience it. So it's pretty hard to be in the same spot to see a total solar eclipse more than once.
Awesome.
Yeah.
So we have a user on X who asks, will the International Space Station photobomb the eclipse? That would look very cool.
Yeah, and so we just got to hear from, the International Space Station, and the unique thing about our astronauts on board is that they have a totally different vantage point for studying the eclipses, and they get to actually view the shadow of the moon as it passes over the Earth, and there are experiments that we have on board the space station as well. And so, with NASA, we have all of these different eclipse experiments that are taking place, and we try to take advantage of every perspective that we have.
Awesome. So we have a final question from Dante. This is going to be a quick one.
Okay.
But Dante on Facebook, who wants to know, will the moon block solar wind along its path during this Ring of Fire eclipse?
Oh, I love that question. So the solar wind is actually a stream of charged particles that's constantly coming off of the sun, and it interacts with the Earth and other planets in our solar system. Now, the Earth's magnetic field actually blocks a majority of those particles from interacting with Earth. Some are able to get through and interact with our upper atmosphere, but for the sake of the eclipse, most of the particles will still kind of be able to be deflected around the Earth's magnetic field. There will be some that are able to interact with the moon, but it wouldn't have a huge impact on what we experience at Earth.
Fantastic. Thank you so much, Gina. And thank you to everybody sending in these questions online. We will get to some more of what you want to know by later on in the show. So keep sending those questions in using the hashtag AskNASA. Now let's check in with Joy and Michael to see what's new in Albuquerque. Joy, how's it going?
Thanks to her and Gina. So we're just under 30 minutes away from annularity in Albuquerque, New Mexico. Michael, shall we put on our glasses to see what the sun and moon are doing?
Yeah, let's do it.
Okay.
Okay, so you're seeing a deep partial solar eclipse. More than half the sun is blocked out, and so you just see a crescent of sunlight peeking out.
Wow, that is amazing. Annularity is just going to be stunning. I can't wait.
Oh, I can't wait either. This is terribly exciting. You can see a balloon inflating behind us. We have annularity coming. It is all coming together today.
I just can't believe that an annular eclipse is happening at the same time as the fiesta.
It really feels special, doesn't it?
And actually, earlier this week, I even got to fly in a hot air balloon, which is just amazing.
That's fantastic.
I met an amazing balloon pilot, Jonathan Wolf, who's been launching balloons in Albuquerque for decades. So let's take a look at our ride. So for complete newbies, how does a hot air balloon work?
It's a great question. It's physics, simply. We heat up the air inside the balloon, and that makes it less dense. And then now, what that means, though, is we can only control up and down. The way we fly and the way we navigate is by choosing different layers of air.
And I heard that there is a box, the Albuquerque box. Could you explain what that means?
Certainly, it's one of the reasons why Albuquerque is a famous place for ballooning. Sometimes what happens is at a higher elevation, the wind is going to the north, and then the surface is going to the south. That's what we call the Albuquerque box. Sometimes the box works out such that you can fly to the south and go up, fly to the north, and then come down and fly back south and land right where you took off, which is an extraordinary, wonderful accomplishment. It's super fun when you can do that.
So for someone who's never been in a balloon, what is it like?
It's unlike any other form of flying. In a balloon, you're actually outside, right? You're standing in a little basket, and there's no windows. You're just out there in the air, and it's just science, right? It's buoyancy, like I said, it's applied physics, but it feels like magic. It's a ballooner eclipse.
Oh yeah!
It's very calm. There's no movement, no wind. When you're moving with the wind, so you're at equilibrium. It feels very calm and peaceful. At the same time, it's really exciting, it's intense. So it's this wonderful combination of intensity and mellow, serene, tranquil, beauty, absorbing nature. You can never experience that in any other form of flight.
Wow, that brings back great memories. And if you can hear the wind behind us, they're actually inflating the balloon I rode in just behind us, which is so cool.
So was that your first balloon ride?
It was my first balloon ride, yes.
Oh my goodness, how did it go? I remember taking one about 20 years ago and it was fantastic. What was your experience?
The most surprising thing is that when you're up there, you don't feel any wind against you because you're actually moving with the wind, so it feels completely calm.
That's fantastic. So would you do it again? I found it terribly relaxing.
100%, yes. So it was actually also not that chilly, and we were only a few hundred feet off the ground as well.
Wow, that's amazing because it's been chilly here all morning.
So as we learned earlier, NASA's scientific balloons fly much higher. They actually reach a part of our upper atmosphere where our International Space Station lives and where some of our satellites fly as well. So it's really important we learn about this upper region and how it could affect our lives on Earth. And NASA and NOAA are two agencies in the US that work together to help study this. And I'm joined with two people who can tell us more. So we have Dr. Elsie Talat from NOAA and Dr. Kelly Corrick from NASA. Thank you both so much for joining us. Very excited to be here. Thank you so much. So let's start off with the basics. Elsie, what are those changes we see in that upper region?
Well, part of what we call space weather, which is the variable conditions on the sun, the Earth, and near Earth space due to solar and geomagnetic activity and storms. And that can affect human activity and our technological infrastructure.
Oh, fascinating. So, Kelly, how does space weather actually affect our life here on Earth?
Well, Elsie alluded to the fact that it challenges our technology. So our power grids are sensitive to those currents that can be induced by this, as well as our satellites could also be impacted by these flares or the space weather. And we get some beautiful things too. We get the aurora out of it.
Have you ever seen the aurora?
I have. It was absolutely beautiful. I laid on the ground for hours in the snow watching it.
So, talking about space weather and the activity in our upper atmosphere, how do NOAA and NASA work together to better understand those phenomena?
NOAA is a go-to resource for space weather information. It watches the sun and the Earth 24/7, and it's the nation's official source of forecast warnings and alerts for space weather to help decision makers prevent and mitigate the effects of space weather here on Earth. And in order to do this, we need information, and NOAA works with NASA to design, develop, and deploy space weather operational satellites to safeguard our society.
And what's NASA's role?
So NASA is a partner with NOAA, and we focus on the science and make sure that we're understanding our star and can do better and better predictions. So scientists use models and the data from all of these satellites in order to better understand space weather.
And what are some of the biggest mysteries around space weather? What don't we know about it?
Oh, there's so much. I mean, let's start at the sun, right? That's the focus today. Even how to predict flares long term, or those large coronal mass ejections, those billions of tons of material that come off. We don't quite know how to predict them for a long term yet.
Well, I'm so glad we have two agencies on the case. Thank you both, Elsie and Kelly. Thank you both for joining us. So, did you know that space weather is also affected by solar eclipses? One citizen science project does experiments during the annular solar eclipse and the total solar eclipse. So, let's learn more about that project.
When the moon blocks the sun during a solar eclipse, there is a noticeable impact on Earth's upper atmosphere, known as the ionosphere. These changes can affect radio communications, including amateur radio, also known as ham radio.
Ham radio is a way you can talk to people all around the world. You set up a radio and an antenna. You talk into the radio,